Now we're gonna take the first derivative of the quotient of two functions. If f and g are two differentiable functions with respect to x and y equals fx over gx, so we have a quotient, then dy over dx equals f dash of x times g of x minus g dash of x times f of x over g of x all squared. So the derivative of the quotient of two differentiable functions equals the derivative of the numerator f dash times the denominator g minus the derivative of the denominator g dash times the numerator f over the square of the denominator g squared. So if y equals f over g, so dy over dx equals f dash times g, f dash times g minus g dash times f over g squared. Example, find the first derivative of the following function. Now we have a quotient. To find the first derivative, by the rule, take derivative of the numerator times the denominator minus derivative of the denominator times the numerator over square of the denominator. So derivative of the numerator, so take derivative of the first term. We have x cubed, start by the exponent 3 times x to the power 3 minus 1 to be 2, so 3x squared. 5 is a constant term, so the derivative is 0. This is the derivative of the numerator. Now multiply by the denominator, x cubed plus 5. If it's a quotient, you subtract, take the derivative of the denominator. We have x cubed, so start by the exponent 3x to the power 3 minus 1 to be 2, so 3x squared. 5 is a constant, so the derivative is 0. 3x squared is the derivative of the denominator. Now multiply by the numerator, so times x cubed minus 5. Down, just put the square of the denominator, so we have x cubed plus 5 all squared. Now simplify by distributive property, so we have 3x to the power 2 plus 3 to be 5 plus 3 times 5 to be 15x squared, so we have 15x squared minus, now distribute this, 3x squared times x cubed to be 3, x to the power 2 plus 3 to be 5, and negative times negative, change the sign to be positive, 3 times 5 to be 15x squared over, keep the denominator squared, no need to expand it. Simplify by combining like terms, 3x to the power 5 minus 3x to the power 5 cancel each other, 15x squared plus 15x squared to be 30x squared, so 30x squared up and down, it's x cubed plus 5 all squared. This is f dash of x, or the first derivative of the given function. Another example, find the first derivative of the given function. We have a quotient, or we have a division of two functions, dy over dx equals, take the derivative of the numerator times the denominator, so start by the first term, derivative of x squared is 2x to the power 2 minus 1 to be 1, minus derivative of 6x equals 6, remove the x of course, derivative of 7, it's a constant, so the derivative is 0. Now multiply this by the denominator, x minus 2, then minus, take the derivative of the denominator, so derivative of x is 1, derivative of negative 2 is 0, this is a constant, times the numerator, x squared minus 6x plus 7. And down we have the square of the denominator, so we have x minus 2 squared. Simplify. 2x times x to be 2x squared, 2x times negative 2 to be negative 4x, then negative 6 times x to be negative 6x, and negative 6 times negative 2 to be positive 12. Then minus, change the sign of each term within brackets, because of the negative sign. So negative x squared plus 6x in minus 7. Down, keep it x minus 2 all squared. Simplify by combining like terms. 2x squared minus x squared to be x squared. 6x minus 6x cancel each other. Minus 4x. 12 minus 7 to be 5. So plus 5. And down it's x minus 2 all squared. So this is y dash or the first derivative of the given function. Another example, find the first derivative of the given function and then find f dash of 0, or find the first derivative at x equals 0. Here we have two terms, each term is a quotient, so f dash equals, for the first part, take the derivative of the numerator times the denominator, so derivative of x is 1 times the denominator x plus 2, then minus the derivative of the denominator, so derivative of x is 1, derivative of 2 is 0, so it's 1 times the numerator x. And down we have x plus 2 all squared. For the second part of the function, it's a quotient, so take the derivative of the numerator times the denominator. So derivative of this is, first derivative of x is 1 minus derivative of 1 is 0, so we have 1 times the denominator x minus 2, then minus, here we have minus, then minus derivative of the denominator, so derivative of x is 1 minus derivative of 2 is 0, so 1 times the numerator x minus 1 and over the denominator squared, so x minus 2 squared. Now simplify. We have 1 outside, so remove the bracket, so x minus x cancel each other, so we have 2 here, 2 over x plus 2 all squared, minus, here it's x, here we have x minus x cancel each other, and negative 2 and minus minus to be plus 1 to be negative 2 plus 1 to be negative 1, so we have negative 1 and down it's x minus 2 all squared. Simplify, the negative sign is cancelled, minus negative 1 change it into plus 1, so this is equal to 2 over x plus 2 all squared and plus 1 over x minus 2 all squared. This is the first derivative of the given function. Now find f dash of 0. So at f dash of 0 equals, substitute 0 for x, so 2 over 0 plus 2 to be 2 squared to be 4, and plus 1 over 0 minus 2 to be negative 2 all squared to be positive 4, so it's 2 plus 1 over 4 to be 3 over 4.